Welcome to our exploration of two climate phenomena that significantly influence our planet's weather patterns, El Niño and La Niña. In this video, we'll delve into what these events are, how they function within the broader context of the El Niño Southern Oscillation, ENSO, and their profound impacts on global weather, economies, and ecosystems. Join us as we uncover the science behind these cycles, their frequency and duration, and their crucial role in shaping our world. 1. What are El Niño and La Niña? El Niño and La Niña are two fascinating climate phenomena that stir curiosity and impact weather patterns worldwide. These events are phases of the El Niño Southern Oscillation, ENSO, a natural cycle occurring in the Pacific Ocean. El Niño is known for its unusually warm ocean temperatures in the central and eastern Pacific, whereas La Niña is identified by cooler than average temperatures in those same regions. This warm and cool cycle significantly influences global weather, affecting everything from local temperatures to rainfall patterns. While their scientific names may sound complex, at their core, El Niño and La Niña are about shifts in ocean temperatures and atmospheric conditions. These changes might seem abstract, but they have very real effects on our daily lives and the environment around us. 2. How ENSO works. The ENSO phenomenon is like a dance between the ocean and the atmosphere, primarily taking place in the tropical Pacific. This interaction is not just a local affair, it has a global stage, influencing weather conditions across continents. When the ocean warms or cools, it affects air pressures, which in turn alters wind patterns. These changes can lead to shifts in weather, affecting rainfall, temperature, and even wind directions. Imagine ENSO as a conductor leading an orchestra. The ocean and atmosphere are instruments playing a symphony that weaves through global weather patterns. This symphony can bring about storms, droughts, and other weather extremes, all depending on whether El Niño or La Niña is at play. 3. Frequency and duration. El Niño and La Niña events are not rare occurrences, they happen every 2 to 7 years. Each event typically lasts between 9 to 12 months, but sometimes, particularly strong events can linger longer. This cycle of warming and cooling is like the ticking of a clock, marking time in the climate world. The regularity of these events allows scientists to study and predict their occurrences, although the exact timing and intensity can still be quite unpredictable. Understanding the frequency and duration of ENSO is crucial for preparing for its impacts, much like how knowing the seasons helps us prepare for changes in weather. 4. Impact on global weather. The effects of El Niño and La Niña are felt far beyond the Pacific Ocean. El Niño is often associated with increased rainfall in South America, leading to potential flooding, while Australia and Southeast Asia might experience droughts. Conversely, La Niña tends to bring dry conditions to South America but results in heavy rainfall in Australia and Southeast Asia. In parts of North America, El Niño can cause warmer winters, whereas La Niña might lead to cooler ones. These weather changes can affect agriculture, water resources, and even daily life, highlighting the importance of understanding these phenomena. It's like a seesaw of weather effects, with each phase tipping the balance in different directions. 5. Economic and human impacts. The economic and human impacts of El Niño and La Niña are profound and varied. For instance, El Niño can disrupt fisheries by reducing nutrient upwelling, particularly off the coast of South America, affecting livelihoods dependent on fishing. On the other hand, La Niña can sometimes boost agricultural output in certain regions but might also cause flooding in others, damaging crops and infrastructure. These events can lead to food shortages, economic losses, and even forced migration in extreme cases. Understanding these impacts is crucial for planning and mitigation, much like how knowing the weather helps farmers decide when to plant their crops. 6. Global temperature trends. El Niño and La Niña play significant roles in global temperature trends. During El Niño, the ocean releases stored heat into the atmosphere, leading to temporary spikes in global temperatures. This can contribute to short-term global warming, making headlines with record-breaking temperatures. Conversely, La Niña often leads to cooler global temperatures due to enhanced ocean heat absorption. This cycle of warming and cooling is an important piece of the climate puzzle, influencing long-term climate trends and highlighting the dynamic nature of Earth's climate system. It's like the Earth's thermostat, with El Niño turning up the heat and La Niña dialing it down. 7. Hurricane activity. The influence of ENSO extends to hurricane activity, showing how interconnected our global climate truly is. During El Niño, increased wind shear in the Atlantic tends to suppress hurricane formation, while cyclone activity in the Pacific may be enhanced. On the flip side, La Niña conditions often lead to more hurricanes in the Atlantic, thanks to reduced wind shear, but can reduce cyclone activity in the Pacific. This complex relationship between ENSO and hurricanes underscores the importance of understanding these phenomena for better weather prediction and preparedness. It's like a game of cat and mouse, with ENSO playing a crucial role in deciding the outcome. 8. Role of trade winds. Trade winds are key players in the ENSO story, affecting how El Niño and La Niña develop. During El Niño, weakened trade winds allow warm water to accumulate in the eastern Pacific, setting the stage for the warm phase. In contrast, strong trade winds during La Niña push warm water westward, bringing cooler water to the surface in the eastern Pacific. This dynamic is like a conveyor belt, moving ocean heat around and influencing global weather patterns. Understanding the role of trade winds helps scientists predict ENSO events and their potential impacts, much like knowing the gears in a machine helps predict its function. 9. Environmental impacts. The environmental impacts of El Niño and La Niña are as diverse as they are significant. El Niño can cause coral bleaching due to higher sea temperatures, disrupting marine ecosystems and affecting biodiversity. On the other hand, La Niña may promote nutrient upwelling, benefiting some ecosystems but possibly exacerbating weather extremes like flooding. These changes can have cascading effects on wildlife, habitats, and even human communities that rely on natural resources. Understanding these impacts is crucial for conservation efforts and sustainable resource management, much like knowing the ingredients in a recipe helps achieve the desired dish. 10. Forecasting and monitoring. Forecasting and monitoring ENSO is a critical endeavor for scientists and policymakers alike. Using tools like satellites, ocean buoys, and sophisticated climate models, scientists can track the development of El Niño and La Niña events. Early detection allows for better prediction of weather impacts, helping to mitigate risks in agriculture, infrastructure, and disaster preparedness. It's like having a weather forecast for the future, providing valuable insights to help communities brace for the changes ahead. By understanding ENSO, we can better prepare for its effects, much like how knowing the forecast helps us decide whether to carry an umbrella.